All right, the question was about factoring these expressions where you have to take out the GCF when you have like a fraction for an exponent or negative exponents. And again, this is a really important thing. This is probably the most common type of factoring that comes up in calculus. So this is why this is an important thing for us to practice this year. So I appreciate this question. Before we look at that, I want to kind of just talk about factoring GCF in general so that we can sort of extend these things a little bit here. So let's say, for example, let's start with something that we know how to do. Let's say I've got like 4x to the third minus 2x to the sixth. And I think every single one of us would look at this and know that the greatest common factor is going to be 2x to the third. And when we divide that out, we get 2 minus x to the third. Now, we've gotten so good at this that we don't even think about what we're doing when we do it anymore. But what you have to remember, where this piece came from is because once we identified our GCF, we came up here and in our head, we just say factor out the GCF because we know what that means now. But what we are doing is we're going back and we're dividing both of those terms by 2x to the third. And so 4 divided by 2, that's where the 2 comes from. And then x cubed divided by itself, since those are an exact match, they divide out and make a 1, which is why all we have left is the 2. Then on the other one, negative 2 divided by 2, the 2's divide out, we're left with a negative 1, which we don't really need to write. And then here, because these are not an exact match, the rule is that we keep the base the same and we subtract the exponents. So that's where this x to the third comes from, okay? Now, let's talk about properties of exponents a little bit. We know that when we divide, we subtract. So here's a few things that we're really familiar with. When we have something like x to the 7th divided by x to the 4th, we know that we subtract 7 and 4, we keep the base of x, and we get 3 as our new exponent. But notice what we all do now without thinking is we keep the base of x the same. That is still going to be true if I have something like x plus 1 to the 7th divided by x plus 1 to the 4th. The base is x plus 1, but the rule is we keep the base the same and we subtract the exponents, okay? This is the part that a lot of us are missing when we do these factoring. Once we expand the bases a little bit, we start getting a little bit confused. So I want you to keep those things in mind as we look at these two examples. Whoa, nope, restart later. Okay, so for number 11, we want to look and determine what the greatest common factor is for these two terms. So the first place we look is at the coefficients, 16 and 32. And I know that I can divide both of those by 16. So 16 is going to be part of my GCF. Then we see that we have x's in both terms. To choose the GCF, we choose the smallest of the powers, which would be negative 3/4. So x to the negative 3/4 is what we're going to set up for our GCF. Now, once again, remember, we're so used to doing this part in our head that we forget what it is that we're doing. Our next step is to come back up here and divide each of these terms, and you can either do it mentally or write it down, it doesn't matter. Divide each of these terms by 16x to the 3/4. Well, here, 16 divided by 16, that makes 1. And x to the negative 3/4 divided by x to the negative 3/4, that makes 1. So we just have a 1 left over. Remember, it's not 0. That's why we have to be careful with that word cancel. Then we come to the next one, and I've got 32 divided by 16, that's 2. And then I look at these two, and I see that they're not an exact match, so they're not just going to divide out. So again, the rule is that we subtract the exponents, and we keep the base the same. Now, if I subtract a negative, that really means I'm adding a positive, and we end up with 4/4, which is the same thing as just x to the first, okay? And that's all we got left. Now, we need to kind of clean up this expression a little bit. So I notice that I have an x that has a negative exponent on it. The 16 does not. 16 is to the positive 1 power. So everything with positive exponents stays on the top. So that's going to be the 16 and the 1 plus 2x. But then to make that exponent positive, x to the 3/4 has to move down below. And there's nothing left to simplify there. Could you distribute that 16? Absolutely. Do we need to? Definitely not. So we can go ahead and leave it like that. Okay. Let's look at number 12. This is one that has a little bit more involved in the base, but the process is exactly the same. So once again, we're going to choose our GCF. So we look first at the coefficients. I have a 4 here and just a 1 here. So 1 is the only thing I can take out. I also see that I have an x in this term, but I don't have one in this term, so I can't take an x out. But they do both have x minus 4 in common. But then I need to look at the exponents and decide which one is smaller. And we know that negative 1/2 is smaller than positive 1/2. So that's going to be the GCF that we choose to take out. So now we come up here and we need to divide each term by x minus 4 to the negative 1/2. And again, the parentheses do matter here because that entire quantity is our base. Okay, so we look here and I compare these exponents. They do not match exactly. I also look here and I'm doing 4 divided by 1, so that means I get to keep a 4. Since those don't match exactly, we have to keep our base of x minus 4, and then I'm going to write kind of my thinking out a long way here. Then I have to do 1/2 minus negative 1/2. And you can certainly do that part in your head. You don't need to write it down, but I'm going to put it there for now so we can kind of see what's going on. And I think I'm going to run out of space, so let me just slide this over just a smidgen. Okay. Now we look at the next term, and nothing is there to divide out that x, so I'm going to go ahead and just bring it down. But I do see on this one that these match exactly, so those are going to divide out and make a 1. So x is all we've got left. Okay? The only time your base goes away is if the entire term divides out. If it doesn't, then the base is going to stay there. And so now we can clean this up a tiny bit. So, we have this x minus 4 to the negative 1/2. We'll move that in a second, but let's clean up in here first. 1/2 minus negative 1/2 just comes out to be 1. So that means this is really x minus 4 to the first, which doesn't really matter. So we can distribute that 4. So I get 4x minus 16 minus x, which means that this simplifies to 3x minus 16, and this has a negative exponent, so it has to move to the denominator. And so that's what we get there. And you're done. Now, you could rewrite this this fraction exponent as a square root if you want. You don't need to, and it's perfectly fine to leave it like that. But a 1/2 power is just as good. So I would just go ahead and stop right here.